Let us get into it. We're going to talk about world wrap. World wrapping is a mechanic where a player or an object can run off the screen and it will wrap it around. So if you fall off of the edge of the world on the right, you'll appear magically back on the left side. We're going to start by creating a new project. First thing we got to do is make a node 2 for the main node. And then I'm going to go ahead and create a player node and give it a little collision shape and a polygon. Let's make it a diamond. And then we're going to go for just like a pretty simple top-down movement script here. We're going to get the velocity for X by getting the action strength of the user input for the right and the left and combining those together. I combined the right and the left and the up and the down to make the code a little bit simpler to read. And we're going to multiply that by the speed that we want to go. We'll then stick that into the move and slide function, which will apply our velocity to our object. I'm also going to normalize our velocity. The reason why normalizing is important is because if we don't normalize, then when we travel diagonally, we'll actually be going faster than the speed that we want to go. The reason for this is because traveling diagonally across a square is covering more space than it would be if we were traveling just along one edge. So normalizing a vector means that the magnitude of a vector will always be 1. The way that they do that is basically, if you have a vector 2, for example, all of the parts of that vector added together, so the x and the y, will equal 1. No more or no less than 1. This way, when we travel at a diagonal, then it will not be greater than our speed. If I comment out the normalized bit, then we can see when we travel diagonally, we go really fast. It kind of makes the movement feel less consistent. Next, we're going to make the player wrap. So in order to do this, we're going to start by creating a new node 2D, and this is going to be a group for all of the platforms and collisions that are going to be static in our world that the player will interact with. It will also handle wrapping the player around the playable area. So let's name that node 2 platform group, and then we'll add a area 2D node, and let's rename it player wrap boundary. We'll give it a collision shape, and I'm going to make the size equal to the size of the window that we have for this game. Now to find the window size, you can always go to your project menu and then project settings, and then under the display category, click window, and then you'll see the width and the height. Next, we're going to add a script to the player wrap boundary. This script is going to take care of wrapping the player every time the player exits the screen area. Delete all the boilerplate code, and we'll go back into the editor, go to the node signal section, and double click on the body exit. This should have created a method for us in our script file, but it looks like it's acting a little bit weird. Godot sometimes does that when you're using an external editor like I do, so I'll go ahead and just write the function in with the matching name. Because this is the player wrap boundary, we only want to wrap if we detect the player node leaves. So the first thing we're going to do is we're going to check if the body that exited was the player node. We can do this by going back to the player script and naming the class player. This way we can check to see if the node that's passed in matches the player type. If the body is the player, then we're going to want to wrap the position. We'll start with the X position. Now, to wrap the position basically means to constrain the position, which in our case is going to be in between 0 and the width of our window, which is 1024. We don't have to hard code that though. We can get that as a variable by using getViewportRect.size.x. If the value that we want to wrap is outside of the range that we give it, then this function will wrap, obviously, that value around so that it stays in the bounds. Cool. We'll do that same thing for the Y value. It breaks when I leave the screen and doesn't wrap. So let's see what's going on. It says there is a signal error calling method from the signal. Looks like I misspelled the function. It's supposed to be on player wrap boundary body exited. And there we go. Now it's working. It feels so nice. Oh my gosh. You can see that this doesn't look super great. It's very jittery. and we don't wrap around until we completely leave the screen. Let's fix that next. Oh, stretch. So when I was first doing world wrap, figuring out how to make it not jittery was something that I looked online a lot for. The best solution that I found was to basically just create duplicates of your sprite or visible object and have them strategically placed so that when you are halfway off the screen, your little duplicate buddy is also slightly on the screen on the other side. So let's go into the player and let's create some of these duplicate buddies. I'm going to create a new function called dupe polygon, and I'm going to pass in the position that I want to duplicate this polygon to. We'll start off by duplicating the polygon and then setting this position to the new position that I'm passing into the function, and then adding it as a child to the player object. In the ready function, I'm going to create all of these duplicates. So let's define the positions that we want to have duplicate polygons at. Because our world wraps in both the left, right, up, and down directions, we actually need 6, 7, 8. We need 8 duplicates, which is a lot, but is needed because there are positions that your character can be in that will require 4 of your duplicates to be showing on the screen. Or 3. Yeah, something like that. Are you leaving?
Yes.
Okay, I will move.
Sorry.
No, you're fine. A mosquito. We're super gonna die up here. Oh, jeez. Let's define the positions that we're going to want our duplicate polygons at. We're going to want them at the right, left, down, and up positions, offset by the window size. Let's loop through these duplicate poly positions and call the duplicate polygon method. All right, let's test. Yeah, looks like it's working. Moving around, I do see that I am missing a few of those duplicate positions that I think I will need. We're going to need our right down, our right up, and our left down and our left up. So we essentially have a grid of 9 and we are the center. So it is us and 8 duplicates. Okay, they show up now when I'm in the corners. Perfect. I'm gonna create a camera so that we can see that grid of 9 that I was talking about. So when we take our camera and we zoom out, you can see all 9 of our duplicates and how they're moving and wrapping. Let's say that we don't want our camera to be still. We want our camera to follow our player. This introduces some problems. We can better see them if we have some obstacles that we're trying to navigate around. First, let's add a camera to our player node, and we'll switch the zoom back to 1, 1. Now we have our camera following our player. When our camera's following our player, we don't really need all the duplicates because there's no way we could see more than one of our player on screen at a time. Okay, next let's go into the platform group. Let's create a node 2D and we'll rename it platforms. And in there, let's add a static body 2D and then give it a collision shape. I made mine like a W type thing. Now when you see we move around, when the object goes off screen, it will seem to wrap around, but it's really us who's wrapping around. We can see this if we turn the camera off for a second. This has a lot of problems though, because when the player is moving, it's able to see past that play area. And because there are no duplicate platforms, it seems that the platform is disappearing and reappearing. So let's add some duplicates to that platform group. We will start by creating a script on the platform group, deleting all the boilerplate code. I really just need to check the box that says don't spawn with boilerplate code. And let's just copy paste all those duplicate positions that we had in our player node into our platform group. Let's switch all the polygon 2Ds to our platform and rename the variables so that they make sense. Let's also duplicate over the dupe polygon method because it's basically the same, and repurpose it for the duplicate platforms method. So let's take a look at this with our zoomed out camera so we can see if it's all working. And it is. There's our grid of 9. When we put the camera back on the player, we see that it moves around as if it's an endless maze full of these obstacles. While coding this up, I kind of was feeling like this should maybe go in like a global script of some kind, because creating duplicates seemed like something that would happen a lot. I'm going to show you how to make a global script. We're going to create a new script. We're not going to attach it to anything right now. And let's name it wrap, because it's about wrapping stuff. Like presents and creatures. Not presents, just creatures. Diamond creatures. That's dumb boilerplate code. I don't know why. I mean, I know why they call it boilerplate code, I guess, but like, who came up with that? I guess I could go look it up. Maybe I'll go look it up and I'll tell you. Okay, so let's create a function and let's call it duplicate for wrap. And we always know the duplicate positions that we're going to want. They're going to be in that grid format. So we can go ahead and define those beforehand. I tried to do it in a constant, but it wasn't liking that I was calling getViewRect, I think. So I just made it a variable instead. And that worked. So woo, whatever works. I probably could make this into like some kind of cool matrix math, but I was really bad at that in school. If you're good at matrix math and you know how you would do this to make it more efficient, I would love to know how to do it. Our global duplicate for wrap method is going to need a little bit more information than we were giving it in our other scripts. We're going to need the node to duplicate, and we're also going to need the parent so that we can know where to add the duplicates as children. We'll iterate through the duplicate positions that we have. We will create a duplicate of whatever node they pass us that they want to duplicate. I guess they in this case is me and you, if you're following along. So that's us. And we will set the position to the position in our duplicate position array, and then we will add it as a child to the parent. So before we can use our global script, we need to add it as a global script. So it's really easy. You just go to project settings, and then at the very top, go to the auto load tab. In the path area, there's a little folder icon. You can click on that and then choose the wrap script and then click add. So let's go to our platform group script now, and let's delete all of the stuff that we coded in there. Let's call our global scripts now by typing wrap.duplicate for wrap. We first want to pass in our node to duplicate, which in our case is going to be our platforms, and then the parent, which is ourself. And I think that's it. So let's go ahead and run it. And yep, you see, it's got all the 8 duplicates made for us around us. So there's 9 of us total. This is super useful because let's say for some reason we wanted to change our camera and we wanted to have a bunch of duplicates of our player again. All you would have to do is go to our player script, go to the ready function, and add our wrap.duplicate for wrap, pass in our polygon 2D and ourself as the parent, and there we are. We have all of our duplicates. Phenomenal. This makes adding things like friends or enemies really easy too, because you can just give them all their duplicates using that global script that we created. For example's sake, let's create a friend. We'll use a kinematic body 2D node, and we'll give it a collision shape and a polygon 2D. I'm going to make it like a bow tie, and I'm going to just give it like a constant velocity moving at a diagonal. There's a few ways to add it to that boundary so that it starts to wrap. The first one that we can do, easiest, is to just go and repurpose our player wrap boundary so it's a little bit more generic. We'll take out the player specification, we'll just make it wrap the body, turn on the collision mask for the friend, and there we go. Now because it wraps, it's going to still do that like weird flickery thing, so we're going to have to add some duplicates for our friend. We'll just add to our ready function the wrap.duplicate for wrap and pass in our friend's polygon 2D and the friend, and there you go. This works if the camera is going to be stationary. If the camera is going to follow the player, this unfortunately breaks because it could collide with the duplicate of the friend instead of the actual friend. And this is a problem because the collision shape is only attached to one of the friends, the one in the center. In order to solve this, the way that I did it is I created a separate boundary notifier for anything that the player interacts with, such as friends or enemies or objects. It works exactly the same as the one that we currently have in the platform group, but instead of wrapping between 0 and the size of the window, it's going to wrap around the player. That means our boundary is going to be negative half a window from our player and positive half a window in the left and right and up and down directions. So in order to implement this, let's go to our player node and we will create a area 2D node and a collision shape. And we'll update the code a little bit so that it wraps around the parent's position minus half the size of the rect, like we said, and then the parent's position plus half the size of the rect. There we go. Now it is wrapping and our character will always interact with the friend that has the collision shape attached to it. So let's do a quick little view of what it looks like when all of the things are going on at the same time and we are zoomed out so you can see all the duplicates kind of like spazzing around. It's like a little ballet. Some things to keep in mind when you wrap. It's very resource intensive because you are creating a lot of duplicates of resources in order to compensate for those edge cases. Hope this was helpful, and that's all I got. So stay safe.